Welcome. Today we're going to talk about arrays. So let's think about what the problem is that arrays are an attempt to solve in Java. It often happens in programming that we have many variables of the same type which are systematically related in some way. They go together. And here's an example where we might have 10 of them. Suppose that we want 10 different double variables, A0 through A9, and they're each going to be initialized to 0.0, and later in the program we're going to want to set, say, A4 to 3.0, and perhaps a bit later we might want to set A4 to 8.5, and later on we might want to do something with two appropriate variables from this collection of related variables. This is all a bit inefficient, and in particular the fact that we had to write 10 separate initialization lines for the elements of that related set of variables is a bit sad. So how do we do that? We'd really much rather be able to do something like this. We'd like to be able to say, well, let's have a collection of 10 doubles all initialized to 0.0. And then in some circumstances we would like to be able to treat them uniformly. For example, we might like to be able to write a for loop to iterate over them. So in Java we can do that kind of thing. Here's an easy alternative to initializing 10 variables of the same type one at a time. In Java, this line at the top here declares an array called A of doubles, and it allocates space for 10 of those variables, each of type double, creates each one and initializes it. And later on we can refer to individual variables from that collection of 10 double variables by just giving in square brackets the index of the variable we wish to refer to. And we can do that whether we wish to set a new value for one of those variables or whether we wish to read the current value out of one of those variables in order to do some calculation and perhaps assign the value of some unrelated variable like x in that bottom line. But we'll go through this in a lot more detail and you'll see how it works. The great thing is that it doesn't just work with 10, it also works with very large numbers. So arrays allow us to store and manipulate large quantities of data, and they are only one of a number of different mechanisms for doing this in Java. They're the first one we're going to meet. Later on we'll meet collection classes, which give us a lot of different ways of doing it with different properties for other circumstances. An array in particular is an indexed sequence of values of the same type. Indexed means, as you see in this table on the right, that we have a notion of what the number of a particular element is. So on the right we have a table of Scottish girls' names dating from 2007, which must have been the most recent data available back in the mists of time when the first version of these slides was created. And so what we're saying is that the 0th element of our list is Rebecca, the first element is Isla, and so on up to the 9th element of the list is Amy. We'll have something else to say in a moment about the fact that we start at 0, but for now just notice it. The kinds of situations we might want to model with arrays include 52 playing cards in a deck. You could think about using an array to capture the 17,000 undergraduates in the University of Edinburgh. It's actually unlikely that you would want to do that in an array, but you could. Of course, collections get arbitrarily large, and there are pros and cons to different ways of handling them in Java. But these are the kinds of situations where we might want to be able to talk about related collections of data using related collections of variables, and we definitely would not want to be writing as many lines of code as there are data in order to initialize these variables, for example. Here's a classic picture as to how to think about an array, and you can think about this as being how it is laid out in memory. It's a little bit oversimplified, but it's roughly speaking how it is. So here we have an array with length 5, so there are 5 different related boxes in this array. And what we've got is we've got an index for each box. So index 0 is a label for the left-hand box in that collection of boxes. The green blob there is the current contents of the box at index 3. The idea is that we can replace the contents of any one of these boxes independently if we wish, and we can always go and read the content of any one of these boxes independently whenever we wish. That's what the square bracket notation you saw a moment ago, and we'll see a lot more of in the coming slides, was doing. But we can also think about this block as being a unified whole. We can think about the whole thing, all 5 boxes, each with their indexes, as being an array, a thing that we can handle as a whole, as a thing in its own right. And we can do things like start at index 0 and go up the array 1 box at a time. And it's this fact that we can think about the array either as a thing in its own right or as a collection of individual elements that gives us its power. And here's another way of thinking about what happens in memory. If we set our primitive variables a0 through a4 independently, then they would each get their initial value, 0 as we set it in 1 line per variable, the way we saw to start with. If we initialize an array, we can systematically put 0 in for all those elements. But also, in the case that we have primitives, there's no systematic way of getting from a0 to a2. They're unrelated primitive variables. Whereas in the case of the array a, there is a systematic way of going from the 0th element of the array through to the 2nd element of the array. And this may be a bit mysterious at the moment, but it will become clearer as we go on. In Java, arrays are considered objects. They're actually a very special kind of object, and the reason is really to do with the history of how Java is related to its predecessor languages, C++ and C. So this can sometimes be a little bit confusing, but just watch out for the syntax we use for arrays in Java. In some ways they are like other objects that we'll be meeting more later on, and in other ways they are special. We talked at the very beginning about objects having state, behavior and identity, and about there being classes of related objects. The class that we've seen most of so far is string. So an individual string object is an element of the string class, and I don't remember at this point exactly how much of its object-like behavior you've already seen, but I think you've seen things like the ability to send a length message to a string. So Java has special support for arrays, and the line that we already saw was the line that allows us to declare, create and initialize an array. We declare it using a declaration that doesn't look very different from the declaration of, say, an integer, and it's the square bracket there that tells us that array of ints is not just an integer, but in fact an array of integers. There's nothing there so far to say how long that array is supposed to be, and so at that stage it's not possible, for example, for the compiler to say how much space should be allocated for the array. Unlike the situation you see where if you declare an integer, the compiler knows how much space is needed to store one integer and can just allocate it if it wishes at the point where you do that declaration. You don't really need to know what really happens under the hood, but you can see in principle what could be happening in that case. So in order to actually create an array of a particular length, we have to have the separate definition line or creation line. And this uses the special keyword new, and the reason it uses it is because an array is an object in Java. So this line is to be read as assign to the variable array of ints, which we just declared to be an integer array, an object which will be a new array of integers of length 10. And that's the syntax for doing it. So the int on the right hand side is the type that should be the type of the elements of the array. If we wanted to declare an array of doubles, we would just have double in place of int there, and so it goes on. Now once you've got your array and it's been created and initialized it, you use the square bracket notation that we briefly saw earlier on to access an element of the array. So you put the index I in square brackets after the name of the array. So here's a rather typical piece of code. We are going to declare an integer n and set it to value 10, and we're going to use that subsequently as the size of an array. We're going to declare an array A, which in this case is going to be an array of doubles. We're going to create the array. In other words, we're going to assign to the array that we just declared a new array of doubles, which is going to have length n. Now notice that the length of the array can be given either explicitly as a literal integer, or, as in this case, by giving an integer variable. Once we've got our array, we can do useful things, like we can use a 3-part for loop to iterate over it. And in this case, what we're doing is the iteration variable of our for loop is going to be I, and then inside the body of the loop we're going to use I as the array index. And so the first time round this loop we have I equals 0, and so the body of the loop expands to A0 equals 0.0, and the next time round we get A1 equals 0.0, and so on, and so we initialize each element using this for loop. That's a bit wordy, and it's convenient that in Java we have a shorter way to do the same thing. So in this case we are just going to keep the declaration and definition of n as 10, and then we're going to declare, create and init the loop in a single line there. Double A equals new double n. There has, of course, to be a convention about what value should be used as the initial value of each element. And in fact what happens is that it's going to be the 0 value, and you can look up what counts as the 0 value for each element that you're interested in, each type that you're interested in. And that's on the next slide. Good. Okay, so for int, double and other numeric types it's the appropriate 0 value. For booleans it's false. It's very common in computer science that false corresponds to 0 and true to 1. Although of course in the type system of Java those are different things. For strings it's going to be null. People sometimes expect it to be the empty string, whereas actually this is the null string, and there's an important difference there which I think we will have more to say about in future. But one thing to notice for the moment is that if you have an empty string, that's a perfectly valid string object, and you can, for example, ask the empty string how long it is, and it will say I am 0 characters long. But you can't ask the null object how long it is, because it isn't even a string at all. It's null. It says I am an object that does not have any value at the moment. But we'll have more to say about that later. All elements of a given array must be of the same type. Later on we will talk about subclassing and inheritance, which allows you to be a little more flexible than that, but you can't, for example, mix up doubles and integers in the same array. So part of your declaration of an array type is always to say what will the type of the elements of this particular array be. So you can have an array of ints, an array of doubles, an array of strings, an array of chars, and so on. Here is how we would instantiate the array of girls' names that was shown on the right hand side of an earlier slide. We can declare that the string array names is going to be an array of strings of length 5. That's what that first line there does. And then we can in turn set each of the elements of the array to the value that we want it to have. Another piece of shorthand. Sometimes it's convenient to have this alternative way for initializing an array. It's useful if you only have a few data items, in particular just as few as will fit on one line very frequently. You can use this curly bracket notation. It's pretty self-explanatory. Instead of having to set the elements individually, you just list them in curly brackets separated by commas on the same line that you are declaring your array. One thing to notice here is that the Java compiler is deducing from the number of initializers that you give what the intended length of the array is, which means that you don't have to specify separately what the length of the array is. So the first line here is equivalent to the code that we had on the previous slide, where we first declared that we were going to have an array names and maybe we created it to say that it was going to have space for 5 string objects, and then separately we set those 5 string objects. Here, by saying these are the elements we would like to be in the string array names, we simultaneously say these are the initial values for those elements of the array names, and we say, by the way, you can see that there are 5 of them, and we don't need to specify that separately. So that's quite convenient. Here are some things that you want to be able to do with arrays. Given an array A, it's often convenient to be able to check the length of the array, and a key thing to notice here is that you just have this syntax a.length. This is not to be confused with the syntax that you would use for checking the length of a string, which if we have a string s, we can check its length by going s.length round brackets. Okay, and that's because arrays are not really proper objects, so it looks as though you're sending the array what is your length message here, but that's not really literally what you're doing. This is special syntax that applies only to arrays that we've got here, as I said, for historical reasons. The first element is always A0, not A1. Arrays start counting from 0. Computer science enumeration often starts from 0, and arrays in Java is one of those cases. And so, correspondingly, the last element of an array is not A at index A.length, but A at index A.length minus 1. Because since we started at 0, we have to stop at length minus 1. Otherwise, we would have too many elements. We would end up with length plus 1 elements in there instead of length. If you use this syntax to try to access an array index, to try to access an array with an index which is too small or too large, Java will at runtime throw a runtime error. And so what you'll see in your runtime error message is a reference to array index out of bounds exception. So if you ever see that, it's a sign that somehow your program has tried to access an array using an index that didn't make sense. So you have to go back and check for that. And we'll see a lot more exceptions and errors in future. So here's another array example. Again, our familiar girls' names. Just here's a few examples of the things we can do with them. So we can, for example, print out the length of that array. We can print out an element of our choice. And we could try, on the third line, to print out the element of the array at index names.length. What will happen if we actually try to run this program? If you're not sure, pause the video here and have a think. Well, we're going to get 5. We're going to get Isla, notice not Rebecca, because of the indexing starting at 0, not 1. And we're going to get an exception, because as I just said, you can't index into an array at index names.length, because the biggest one is index names.length minus 1. Now let's do something slightly more interesting with arrays. You've probably met the concept of dot product in maths at some point. Doesn't matter if you haven't, all you need to know about it is what's on this slide. If we have two vectors, x and y, of the same length, n, then we can form their dot product by taking their corresponding elements, their corresponding components, in pairs, multiplying them together and adding up the results of all those pairwise multiplications. So here's how that looks in code. We can initialize our two arrays x and y to those sequences of double values. Then we can initialize the sum to 0.0, and we can use a two-part for loop in which the iteration variable I is being used simultaneously as the index into array x and the index into y, as you see. And all we're doing here is we're saying each time we want to add to the current value of sum the result of multiplying the ith element of x by the ith element of y, and that gives us the dot product. And so in the bottom you can see a table of what happens if we actually run that code on the given arrays up there. And if you're not sure about that, you might like to pause the video and check the numbers and check that you understand what's going on there. Some more examples. We can create an array using random values. I'm not sure that we've seen the math.random method before. I think that's the only actual new thing here. Math.random is a method which is stored in the math class for convenience. It's a static method. That means that it's a method which is associated with the class rather than with any individual object of it, and you'll see a lot more of that in future. And what it does is it returns you a random double value, which we're now going to put into the array A at the index I. And so we're going to put a bunch of different doubles into this array and store them like that. And we can print them out one at a time, and we can find the maximum of them. What is there to say about this? Not a whole lot, really. In this code we are initializing the maximum double value to be the very first element of the array. That might turn out to be the maximum, or it might not. And then what we're doing is we're iterating over the rest of the array. So this time we're starting the iteration variable I from 1 rather than from 0. We could have started it from 0, it's just it wouldn't have gained us anything. And then we are going to look at each element of the array in turn, and if the current element of the array that we're looking at is bigger than the maximum so far, that's what's going to be stored in max, then we're going to say, we found a bigger element, and so we should set the new value of max to be the value of this element of the array, the one we're looking at the moment. And then we go round the for loop again, and we look at the next element of the array, and so it goes on. Quite often it's useful to copy one array to another, and here's a rather familiar piece of code that does that. In this case we're initializing the array of doubles called A to contain those 5 doubles on the first line. Now we are going to create a new array of doubles called B, and this we do by saying, please give me a new array of doubles whose length is the length of the array A. So this is often what you'll want to do when you want to have 2 arrays of the same length. You'll want to give the length of one array as the initial length, as the given length of the other array. By the way, notice that I haven't told you how to change the length of an array, and that's because there isn't a good way to change the length of an array in Java. The length of an array is fixed from the time when you initially set it. But now we've got these 2 arrays, A and B, and they are the same length, and we can use a for loop to iterate over the elements of array A, and in each case set the corresponding element of array B to be the appropriate value of array A. And the result is we have 2 arrays, A and B, which at this point contain exactly the same values, but they are different arrays, so it would be perfectly fine to change a value in one of those arrays, and it would not result in the corresponding value in the other array automatically changing, because we've just copied them. We've got 2 different arrays that have just been initially set up to have the same values in them. That's all for now.